What's going on, everybody? Welcome to another learning video with Everything EE. Today we're going to be doing a nodal analysis problem. It's pretty classic problem that y'all will do in Circuits 1. We're finding, the whole goal of this is to find voltages at V1, V2, and V3. And we're going to do this using Kirchhoff's current law, which is all the currents going into a node must equal all of the currents going out of the node. So we're going to be describing these currents using their voltage and resistance. So we know here, I equals V over R. And so we're going to be using this identity or this equation throughout this example, this nodal analysis example. Okay, so let's get to it. Let's check out what we got here. We have a 2 amp current source. We have V1 on node 1. We have this 10 ohm resistor. We have this given current, IX, flowing in this direction from higher potential to ground. Notice this is ground. This circuit's drawn kind of weird, but I think it's mostly to just trick you up. We have this 15 ohm resistor. We have this 45 volt source. We have V2. We have a 10 ohm resistor, and we have V3 at node 2. Okay? And we're choosing our node because they have currents going in and out of them. As you can see, V2 is not a node because it's only got one current going through this node, or through this point in the circuit. And then finally we have this dependent current source that is 2 times this IX that's defined up here. Okay, so let's go ahead and start with our nodal analysis, starting with node 1. Okay, so we can see here we have current going into the node here, this 2 amps. Then we have this IX going out of the node. And then we have this, we know that current flows from the minus to positive terminals of this voltage source. So we have current going through this voltage source and kind of through the circuit, just like that. Okay? So if we know that on one side of the equation there will be current going into the node, and then on the other side of the equation there will be current going out of the node, and they're equal to each other. So 2 for 2 amps, this current source, is equal to, let's find this current IX is going to be V1 minus 0 over 10. And then let's get this current going through this 45 volt voltage source, which might seem a little tricky, but if we kind of think forward, right? Think what we've learned before, a current through a single branch is the same through all the elements in that branch, right? And so this would be our branch. So the current going through that 45 volt source is going to be the same current going through this 10 ohm resistor. So we can use that fact to describe the current by saying it is the current through that resistor, which is V2 minus V3 over 10. Okay? So I'm just taking the voltage across this resistor here and then dividing it by its resistance to get the current through that 45 volt source. So let's go ahead and work out some of this math here and clean it up a bit. We got 2 equals V1 over 10. 0 minus 0 over 10 goes away, plus V2 over 10 minus V3 over 10. Let's bring it over here, and we'll say 2 is equal to 1 over 10 V1 plus V2 minus V3. Then we'll multiply 10 on both sides, giving us 20 equals V1 plus V2 minus V3. Alright, so we'll leave it there for now, and we'll just put a 1 here. This will be our equation 1 for now, and we'll move on to node 2. Alright, so node 2 is here, and let's sort of define the currents that are going in and out of this node. We know this dependent source is sending current into the node. We know from before that current is flowing through the negative terminal of this voltage source and out of the positive node coming down, so that's another current going into this node, node 2. And then finally we know that current flows from higher potential to lower potential, so we're going to have this current flowing out of the node from V3 down to ground through this 15 ohm resistor. So let's go ahead and describe this situation here, starting with what's going into the node. So we have a 2ix plus V2 minus V3 over 10. So that takes care of the currents going into the loop, into the node. And then the current going out of the node here is going to be V3 minus 0 over 15. Okay, so let's clean this up a bit. Let's figure out what we're going to do here, right? We need to define something for Ix. And we actually already did here in node 1. We needed Ix to use for one of our currents going out of node 1, and that was this V1 over 10. So we can just plug that in here. 2 times V1 over 10 is our Ix, plus V2 minus V3, and we'll kind of break it out, why not? V3, that 0 goes away, so we're left with V3 over 15. Okay, so let's keep on going. Let's get rid of this 10. So we have 1 over 10, 2v1 plus v2 minus v3 is equal to v3 over 15. Let's multiply both sides by 10 to get rid of this 1 over 10. So we get 2v1 plus v2 minus v3 equals 10 v3 over 15. Simplify this down. This is going to become 2v1 plus v2 minus v3 equals 2v3 over 3. And then let's get v3s. Let's combine the v3s by subtracting 2/3 v3. And there's a 3 over 3 here, right? Because it's 1. So then we will end up with 2v1 plus v2 minus 5 over 3 v3 equals 0. Okay? So this will work as our equation 2. So let's go to the next step. Right now we have 3 unknowns, v1, v2, v3, and only 2 equations. So that's kind of an issue, right? We're lacking an equation, or we're lacking some information. So let's look closer to this circuit here. And what do you see here? What can we define for one of these voltages? Well, we know V2 is sitting right here at the positive terminal of this 45 volt source. So we can actually say that V2 is actually equal to 45 volts. So that's one of our answers. Easy. So let's plug that in here. So 20 equals V1 plus 45 minus V3. And let's move it over, so that gives us minus 25 equals V1, because we subtracted 45 from both sides, just so you guys know. And then V1 minus V3. So that's our new one. Let's go down here and do the same thing. Plug in 45 volts for V2. So then we get, I want to move this up here. Well, after I do this. 2V1 plus 45 minus 5 over 3. V3 equals 0. Let's move things over. So we have 2V1 minus 5 over 3 V3 equals negative 45. That's our new 2. Okay. So now we have two equations, two unknowns. Let's go up here. This is going to be super easy to solve for V1. So V1 is going to equal V3 minus 25. That's our new one. So let's go ahead and plug in equation 1 into equation 2 for V1. So V1 is now V3 minus 25, so 2 times V3 minus 25 minus 5 over 3 V3 equals minus 45. Let's distribute this out to V3 minus 50 minus 5 over 3 V3 equals minus 45. Let's get rid of this. 50 plus 50 plus 50. Let's bring this up a bit. So we end up with 2V3 minus 5 over 3 V3 equals 5. Alright, we're almost done. Let's combine V3. We can get a common denominator of 6 over 3 V3 minus 5 over 3 V3, because 3 times 2 is 6, and we basically did 3 over 3 there. Right, so that's our common denominator, 3 equal to 5, and we end up with 1/3 V3 equals 5. And finally, we multiply by 3 on both sides, and we get V3 equal to 15 volts. So now that we have V3, we can go back up here and solve for V1. V1 is equal to, plugging in for V3, 15 minus 25. So V1 becomes minus 10 volts. Right? And then just recapping, so we get all of our answers. V2 we know is 45 volts from the circuit, and then V3 we solved below, 15 volts. Cool. Alright, y'all. Let me know if you have any comments, or have any other problems that you're interested in seeing, and we'll definitely take a look. As always, please like and subscribe. Thank you very much, and have a great day.